We tend to think of the AI revolution as something happening in the cloud, right? A world of bits and bytes. But what if the biggest challenges for AI's future aren't digital at all? What if they're, well, physical? At this year's Consumer Electronics Show, AI wasn't some distant idea. It was a physical thing, right there in front of us. We saw it in devices like LG's Chore robot and smart tech from Emerson that works completely offline. And this isn't just about making life easier. It's a huge shift. AI is no longer something you just log into. It's becoming this invisible, built-in part of our actual physical world.
And it's not just in our homes, it's getting even closer. It's literally on our heads. Take Razer's Project Motico headset. It uses on-device processing for real-time awareness. That's a perfect example of AI moving out of some far-off data center and right into our immediate space. This is all happening way faster than anyone thought. But as AI gets more physical, it's starting to bump up against some very real, very physical walls.
And yeah, that world is now filling up with robots. I mean, actual robots. AGBot showed off its production-ready humanoids, and get this, they've already deployed over 5,000 of them. These aren't just cool demos. They're in warehouses packing boxes, they're in factories building products, and they're aiming to create the zero-labor home. This really isn't science fiction anymore.
This quote from Tech Republic just hits the nail on the head. The message from the entire industry is loud and clear. The time for just talking about what AI could do? That's over. It is all about execution now.
So, this massive pivot from hype to actually building things, well, it's attracting a historic amount of investment. So the big question is, where is all that money really going? I want you to picture a fire hose of cash, and it's all aimed at one single target: AI. It's kind of staggering. But investors are saying that 90% of all venture capital is now flooding into AI companies. This is one of the biggest concentrations of capital we have ever seen. So you might be wondering, okay, is this just another tech bubble about to pop? Well, not really. The market's grown up. Unlike that speculative free-for-all a few years back, investors today are demanding solid fundamentals and real-world results. The days of just making big promises are over. It's a much more disciplined game now. Okay, let's get into the heart of it. We have the real-world products, we have the focus funding, but this massive AI build-out is now facing a whole new set of problems. And these aren't the kind you can fix with better code. The answer to that question is what's completely reshaping the future of innovation. Because it turns out the biggest hurdles for AI are no longer digital. They are intensely physical. The first physical limit? Energy. Megawatts. Just training one large AI model can use as much electricity as a small city. And as these models get bigger and smarter, their need for power is just going through the roof.
The second limit is molecules. Now, what I mean by that is the processed materials that are the building blocks of all this tech. Everything from the super pure silicon in our chips to the specialized plastics in server racks. Every single piece of AI hardware starts here.
And the third limit is minerals. The raw stuff we literally have to pull out of the earth to make those molecules. So you've got megawatts, molecules, and minerals. These are the new bottlenecks for innovation.
And listen, this isn't just us analysts saying this. The tech leaders themselves are now admitting it publicly, like Mark Zuckerberg said. Energy, not compute, will be the #1 bottleneck to AI progress.
And if you want to understand the scale of that energy problem, just look at this number. By 2030, data centers alone are expected to use 945 terawatt-hours of electricity. To put that in perspective, that's enough energy to power every single home in the United States for a full year. It's just a massive amount.
So this new physical reality is kicking off a global competition. It's a new kind of arms race, really. But this time, the prize isn't military power. It's control over the basic resources of the 21st century.
Now, check this out, because this slide reveals a pretty huge energy gap. China has a massive head start with 29 new nuclear reactors being built right now. The US currently has 0 under construction. This is a real wake-up call, and the United States is now scrambling to try and close that gap.
This dominance also extends to the mineral supply chain. Let's take rare earths. These are 17 elements that are absolutely essential for everything from your smartphone screen to the magnets in electric cars. And as you can see here, China controls the refining process for the vast majority of these, and other critical minerals, which gives it an incredible amount of geopolitical leverage.
So let's look at how the US is starting to push back.
In January, a national energy emergency was declared. Then by March, orders went out to dramatically ramp up domestic mineral production. And in May, we saw new advanced nuclear projects get the green light on federal sites. It's a really clear signal that securing these physical resources is now a top national security issue.
So we've seen how the AI revolution is hitting these physical walls, and how that's kicking off a new global race for resources. But what does all of this really mean for the future of innovation itself?
You know, for decades, we've thought of progress as this intangible thing happening in the cloud. But the new reality is that the speed of the AI revolution is going to be determined by energy availability. Securing mineral supply chains is now a huge economic priority. And the next trillion-dollar opportunities, they might not be in writing software, but in building mines and power plants. This really forces us to rethink who the builders of the future are actually going to be. It's a massive shift, and it's going to have consequences that ripple out everywhere. The future of innovation is no longer just about code. It's about power, in every single sense of the word.